Greetings, comrades. This is part 2 of an exam revision video for the upcoming VCE Psych exam. So check out the link below to access part 1. Ethical concepts, not to be confused with ethical guidelines. Ethical concepts are more broad in terms of the way that research is carried out. So there are 4 concepts. Integrity is simply a commitment by researchers to search for knowledge that will benefit the community, and then the honest reporting of that regardless of whether it aligns with what they were predicting or hoping would happen. Then we get to justice, which has a few elements to it. So we've got to avoid burdening particular sections of society from participating in the research. If we generate some encouraging findings, e.g. a medication that is a breakthrough in terms of treating one of the conditions that we look at in the course, then the participants need access to this. Now, beneficence is simply weighing up the benefits versus the risks. If the risks outweigh the benefits, then an ethics committee will give us a thumbs down on undertaking our research proposal. So therefore, we always aim to maximise the benefits. We acknowledge that there will be some risks, particularly if we're working with vulnerable people, e.g. a mental health study. And once we've got the thumbs up for approval from the ethics committee, then non-maleficence comes into play, meaning that we need to try and minimise the harm. E.g., if we're using systematic desensitisation, which I talked about in part 1, to treat someone with a phobia, then we've got to basically employ measures to gauge how the participants are doing in terms of their well-being when they're exposed to approximations of their phobic stimulus. So respect, a bit of common sense here, but we need to be mindful that this applies to minors and people who might not be in a position to give consent, e.g. someone with a really advanced stage of Alzheimer's or a disabling level of dysfunction on some type of mental health issue. So again, we've always got to be mindful that this person, this being, is a living organism, and to respect their perceptions about things, their beliefs, their customs, etc. Now, ethical guidelines are more specific and more tailored compared to ethical concepts. An ethical guideline needs to be employed by a researcher for a study. So confidentiality, obviously we can't identify a participant in a publication of a study or even their image. Voluntary participation, we can't simply coerce people into being involved in a study just because, say, they're enrolled in a course. That would be a breach of voluntary participation. Informed consent, this one's got the most meat to it. So when you're explaining how informed consent is met as an ethical procedure, we need to basically convey to the participants the nature and the purpose of the study, how we're going to generate our data, any potential risks, and if they're minors or deemed not capable of giving informed consent, then we need also the informed consent of a legal guardian. Now, withdrawal rights might seem obvious, but there's 2 components to this. The participant needs to know that they have the right to withdraw at any point of the study if they are experiencing duress or ill health, but also at the end they can withdraw their results if they're not happy with basically what's been generated based on their involvement. Now, in order to generate valid results, we need to use deception in controlled experiments because we want to see how the IV will affect the DV without letting a placebo effect influence the findings. But we still need to get the thumbs up from an ethics committee in terms of, is our deception warranted? Are there debriefing procedures in place? So importantly, when we get to the end of the study, we debrief our participants. We explain the nature of the deception, we share our results, and we make sure they're okay. And if they're not okay, then we need to offer some type of mechanism of counselling services to ensure that they are restored to the wellbeing level that they're at prior to their involvement in the study. A couple of retro questions here on ethics. This first one is asking about how you'd actually undertake debriefings. So it was a lengthy scenario where the only details that the experimenter had was basically their postal address. So VCE were really picky on this one and said that you couldn't just kind of convey via social media. They didn't have access to that. So we just had to utilize the actual data we had, which was their postal address. So we accessed them via a mail out, and then you needed to explain what the debriefing process was, explaining the findings and offering counselling services if they were experiencing, or if they did experience any distress. Question 40 on this multiple choice question here. When we're studying human sleep patterns, we must ensure patient confidentiality. All right, that's an ethical guideline. We don't debrief them at the start, we debrief at the end. So a play on words here. We don't withhold information about the nature of the study. We do reveal that. There's deception allowed, but we still need to give some broad guidelines in terms of the processes involved. And we are, in terms of the beneficence, non-maleficence concepts, we are allowed to, I guess, have a level of short-term disruption to sleep patterns as long as the benefits outweigh the risks. So in terms of data, we need to be able to differentiate primary versus secondary. So secondaries, I've already talked about that a little bit when we talked about doing a lit review. So if we want to generate some secondary data, we generate a lit review. So therefore, just by doing some good searches, we can get a lot of data at our fingertips, but we have no control over their methodology, how they generated their sample. And then when we're ready, then we generate primary data. So we have control over the way that we manage this. It could be from a case study, it could be from field work, or it could be from a controlled experiment. So therefore we have control and we can determine how many people we're going to sample, our methodology. If it's a controlled experiment, we can dictate how we're going to manipulate our IV to see how it affect our DV. But there is a time, there is a cost involved in that process, but depending on how many people we sample, etc. So qualitative and quantitative. So think about this in relation to a self-report for area study number 1, unit 4, because we can generate both qualitative and quantitative from a self-report about a sleep investigation. So qualitative is we ask open-ended questions so that we get detailed responses, but then the problem with that is, how do we summarize? How do we generalize? How do we ensure external validity? Difficult. Quantitative data, so that's numerical. So we'll think about what we learned in the study design, measures the central tendency, the 3 M's, mean, median, mode, our variability in terms of our standard deviation, and even a graph represents numerical information. So the advantage of that is that it's easy to summarize in a mean, on bar graph, etc., so that we can determine significance by looking at the difference with the means for 2 groups. We can evaluate spread with standard deviation, but we don't get the insights that we do from the qualitative data. So if we think about a sleep study, the person might reveal some of their poor sleep hygiene habits. We're not going to get that from quantitative data in terms of if we're comparing, let's say, the effects of some type of employment of Zeitgeibers or bright light therapy in terms of altering someone's sleep-wake cycle. Now, objective versus subjective data. This is not listed on the study design, but it's just useful when you are evaluating data. So if it's objective, that's observable. So if we can just simply count, something, if we can measure it in time, if we can determine, say, capacity of STM by just identifying how many words they've been able to recall, then the advantage of that is there's no bias. And that enhances our repeatability, reproducibility. But again, we lack detail in terms of the richness that we get from more subjective data. So subjective data, so that's, again, we can get this from a self-report when we ask people about their sleep hygiene habits. So we get that rich detail, but it is prone to bias in terms of the way that the participants are interpreting the question, and even some observer bias in the way that that data is interpreted. Percentage change gets a little bit of airplay in terms of the key skills of the study design. Think about how we learned about percentages when we looked at REM and non-REM over the lifespan in area study number 1, unit 4. So we actually looked at some of the percentage changes as over the lifespan in terms of the proportion of sleep that's determined in REM versus non-REM. So those newborns are having about 50% REM. So by the time we kind of get to mid-childhood, it's back down to that 20% ratio. So the advantage of percentage change is it basically gives us a universal form of proportion, makes it easier when we're looking at durations of sleep, STM capacity, ratings, etc., before and after. If we look at the effectiveness of some type of intervention, so that could be CBT, etc. Now, you won't be doing any calculations on the exam, highly unlikely. Possibly they could ask you to determine the median of, let's say, 5 numbers. So the main thing to be mindful of here is why bother? So the mean is the most useful measure of central tendency, particularly when we have normally distributed data, because it basically utilizes all the scores in our data set and gives us a summary. And so therefore, if, say, we've got a control mean and an experimental mean, then we can graph those, we can look at the difference, we can evaluate significance. That doesn't mean that the median and the mode aren't useful. The mode, the most frequently occurring value, again, it basically provides some, I guess, useful support information, and same with our middle value, the median, because if we have similar means for 2 sets of data, one set might be skewed, and so therefore the median might kind of give us some extra information in terms of, okay, this the median for this data set is slightly higher than this other one. Obviously we've got some skewing of data at one end. So measure of variability of the study, standard deviation. You won't be calculating this on the exam. We just need to be able to interpret it. So it gives us a measure of our spread of our scores from our mean. Not as useful as the mean, but it basically, again, it provides additional information when, if we look at this image here, this yellow data set, very tightly packed. So therefore, we've got a small standard deviation. And so if we're interpreting that, we'd say the scores are pretty consistent. If we look at this blue one here, this dark blue one, the measures of central tendency are similar if we look at the midpoint of the data. But in terms of the spread of scores, we'd have a much bigger standard deviation, indicating there's less consistency in terms of the range of scores. A couple of retro questions here. In essence, this multi-choice question here is asking, when is the mean most useful in terms of our data set? Well, when our data set is normally distributed with our scores tightly clustered around the midpoint, then we could say that mean is a very good representation of our data set. If our data is skewed, if it's widely spread, then outliers might affect our mean. It might drag it up or down, and so therefore we'd say that mean is not as good in terms of its representation of the scores. Now have a look over here. This might be a bit hard to see, but what we have here is a bit of an STM test on rhyming versus non-rhyming words. So we've got a 4.2 mean on the rhyming words, and we've got 6.7, much higher. These people have done much higher when the words don't rhyme. There's less confusion. But look at the standard deviation. We've got a huge, more than double. That's 1.8 there. You might not be able to see that. And we've only got a 0.8 spread for the rhyming one. So how do we interpret this given these two scores are going in opposite directions? So this question is just asking, what does the standard deviation tell us? So, well, what it's telling us is that when the words don't rhyme, we're pretty consistent. So everyone's kind of having a similar effect in terms of non-rhyming. They're not linking it to content in the LTM. They're not getting confused. So our scores are tightly packed around that central point of 6.7. And again, think about the SDM capacity 5 to 9. So we're sitting right in the middle of that. When we have words that rhyme, it's obviously creating a much bigger discrepancy with that 1.8 standard deviation. So therefore, we've got less consistency, a much bigger spread. Some people, the actual use of the rhyming words, it's actually creating a huge effect in a detrimental way in terms of their SDM capacity. Now, you will be working with tables, charts, and graphs on the exam, so we need to have some fundamentals here in terms of how to utilize these. Now, seemingly in recent years, every second year on average, there's some type of graph on the exam and students are asked to label it. And so what we need is a title. We need to label our X and Y axes. And if we're using a bar graph, we need to label what those bars represent and not just group 1 and group 2. What's the difference between them? So if you have to do any graphing on the exam, it's basically asking you to label it in terms of, again, IV, DV, make sure you put it in a heading. We don't need to worry about our scale. If we're working with numbers, they're not going to be picking on that. Again, it's just how we label the X and Y axis, so it clearly communicates to the reader what the graph is showing us. So back in 2017, students were asked what's an advantage of a bar chart. So we just needed to say that it's an effective way of basically demonstrating the frequency of scores. Then we were given just a blank graph like this with a grid, and we're given some statistical information here. And so what we needed to do was basically identify that group 1 had a normal sleep in our first bar, a second one, they were totally sleep deprived for 24 hours, and then the third one had a BAC of 0.05. So it's an alcohol versus sleep deprivation experiment with a control group thrown in. And then we've got our scores here. So we're on our axis here, we've got from 0 to 25. We're labeling it as the mean number of driving errors. So our first bar, we go up to 5, and these other two, we're going up to 22-ish, etc. So a good one to practice. But again, mean number of errors this way, and then we label the 3 conditions. So we've got our control, normal sleep. We've got two variations of the IV, sleep deprived, and then we've got a 0.05 alcohol group. If you're asked a question on the accuracy of data, good idea to reference a true value. So what you'll say is, does that method that we use to measure our data reflect the true value of what it was trying to measure, whether it be SDM capacity, proportions of REM or non-REM? If it's a self-report, probably not, because of the subjectivity of that. Precision, regardless of the accuracy, is our data precise? Is it consistent? Now, on the subject of precision, repeatability is a good way to determine that, because what we'll need to do is repeat the test under the same conditions with the same cohort. And if we're getting the same results, then we can say that that we have precise data. Reproducibility, if we want to determine our external validity, that's when we basically carry out our test under different conditions with a different cohort. So check out this multi-choice question from last year. Again, I think a bit of student fatigue has come into play, given this is question 18. So they're asking, if we want to test about repeatability, what do we do? So a lot of students have gone for C here because they've read the first part of the sentence, the same method. Yeah, that's good. But then read on, then it says for different participants. So therefore that relates to reproducibility. So let's go back to A, which is simplistic, but it's our best option. We test people, the same people, under similar conditions. Now, when discussing the validity of data, we want to basically go back to what we were talking about with accuracy and precision and true value. So is the tool that we're using to measure our DV accurately doing that? If it's a self-report, no, because it's too subjective. If it's objective and it's easy to measure, well, then yes, that's going to enhance our validity. Now, with internal, external, internal is that tool that we were using or method we were using to determine our DV, was it effective for that sample? And if it's objective, and if it's an effective way of measuring the true value accurately, then we'd say yes, the data has a high degree of internal validity. External validity is to what extent would that method generate accurate data if we test beyond our sample. So therefore, if you have low internal validity, you're going to have low external validity, but it is possible to have high internal validity, e.g. if we're testing teens, and our external validity might be low because that method that we use to test teens might not hold up if we're testing adults because of exposure to social media or other kind of generational issues. So again, back to that driver question where we had alcohol versus sleep deprivation and used a driver simulation. The question here is asking, with respect to the investigation, what is meant by validity. So 1 mark if we simply explain that validity is determined by gauging how effectively the method we used was to, measure our DV. And in this case, they're counting the number of driver errors. That's in the tabulated data here. So that is relatively objective. So therefore, you'd go in bat and say, therefore, we're generating internally valid data. But you could argue another way and go, well, hang on, a driver simulation, it's not the same as driving on the road. So therefore, that might diminish our validity. So don't be scared to make a counter argument if you're not sure. But back it up. If you're going to say low validity, why? Because it's not representing the true value of the number of drive errors that we'd have if we're actually on the road. Or it is internally valid because it's an objective means of measuring that variable. Now, we need to be able to explain how errors have affected our data. So it could be a personal error based on a mistake made by the researcher, or it could be something to do with the tool or the method that we use to measure our data, which brings into play systematic and random errors. Now, a systematic error is still precise because we're out by the same amount, same percentage every time because there's some type of fault with the tool that we're using. So it'd be like if you jumped on your scales every day and there's something wrong with the springs on your scales and we're exactly 2 kilograms out every time of the true value of your actual weight. So we'd say that's a systematic error. If a random error is where it's uncertain, it's unpredictable in terms of how effective those scales are in terms of, let's say, they're influenced by heat or air pressure or something like that. So systematic errors, they are precise, random errors are not, and this kind of visual provides a good indication of that. Now, if we have a look at this question from the sample exam, at the start of the question, it actually refers to inconsistency, that some of the data was inconsistent. So therefore, when we're looking at the options here, that eliminates both A and C because it would be consistent in terms of the error. So just look out for little clues like that. Now, if we look at D, the problem with D is that it's talking about repeatability and external validity. So repeatability would relate to internal validity as opposed to reproducibility, where we're testing a different cohort to basically, which would impact the external validity. So again, we need to basically work with what's in front of us and look for some of the indicators. So if we look at B, inconsistencies would cause random errors for the sample group we tested, and that would undermine your internal validity. Now, in terms of the context of the course, sometimes, particularly given we're working with humans, there'll be some uncertainty. We'll have incomplete data. So therefore, we just need to be mindful of that in terms of how we disclose that in our discussion. Outliers we don't ignore. I know there's a bit of that in maths, but we just draw attention to them and go, these outliers might have skewed our data. They might have dragged our mean up, etc. And again, that goes back to why we look at a variety of descriptive statistics, medians, modes, standard deviation, etc. Now, when we're being analytical of our data, we're looking at our evidence. So the evidence is let's say, the quantitative data in front of us. It could be a mean, it could be a standard deviation. That's our evidence. And then when we make a judgment on it, if it's subjective and there's a lack of consensus with our other researchers, then we call that an opinion. And if we make a statement that's an opinion, then we need to do some further testing, particularly in terms of the reproducibility of our findings to see if our opinion holds up when we test different cohorts under different conditions. If we can't back up our gut instinct, our gut kind of interpretation, we call that an anecdotal statement. So this is what we think has happened. I just can't back that up with any evidence. So just be mindful about this terminology from a beefy research scenario that you might see on the exam. Now, when you're asked to draw conclusions, that's not the same as being asked to draw implications. So a conclusion applies to the sample that we've tested. Even if we've rejected our hypothesis, we're still going to draw a conclusion based on the sample tested. But in our discussion, we will point out that we need to be careful in terms of our conclusion, because there might have been some variables that we didn't control. We might have had some type of sample bias because we didn't use stratified sampling, so we might have a problematic gender bias or something like that. So therefore, we make recommendations in terms of enhancing the reproducibility of our findings. We keep coming back to that, don't we? So let's look at an example of writing a conclusion, because if we look at this retro question here, we're asked to draw a conclusion for 3 marks based on this study here. So the first mark was we look at our sample. We've got 18-year-olds, and we need to reference those so that our conclusion has the necessary context. Second mark was for looking at that IV-DV relationship. So this graph has everything we need. We've got the standard condition where we've had a full sleep, and then we've sleep deprived. We've only had 4 hours sleep. So we need to basically convey that we're comparing the same cohort of participants, because it's a within subjects design, over 2 different conditions. And then we need to emphasize the result, that we're basically tracking the number of errors on this visual perception task. And so what we can conclude from our means of the 2 conditions is that we're going way worse when we're sleep deprived on this visual perception task. We don't need to draw implications. It's just asking us for a conclusion based on this study. And finally, if you're asked to draw implications from a study, there's three things we want to tick off. We want to talk about the impact of that study, that experiment might have on our broader population of interest, particularly if we're confident we've got good external validity. We want to bring into play the relevant theory. So if it's anything to do with, say, bright light therapy, we're just going to explain that. We're going to reference how it sends a bright light is exposed, it's detected by the retina, it signals the SCN to do its thing. And then we're going to suggest future research. So again, we can enhance the reproducibility, and then we can basically be more confident in applying those findings to our broader community.